Did you know that cells cannot exist without phospholipids? This is because phospholipids form a bilipid layer that make up cell membranes. Cell membranes play an important role in controlling what goes in and out of a cell. Let's examine the structure of a phospholipid. There are four major parts. First, there is a glycerol backbone, as in all lipids. One end of the glycerol molecule is bonded to two nonpolar and hydrophobic, or water-repelling, fatty acid chains. Often, one carbon chain is saturated with hydrogens. In other words, there are no double bonds. But the other carbon chain is unsaturated due to one or more double bonds that give the chain a bent shape. The other end of the glycerol is bonded to a negatively charged and hydrophilic, or water-attracting, phosphate group. Finally, the phosphate group may be bonded to another organic polar molecule, such as choline. Let's now examine how the overall structure of a phospholipid fits its function in cell membranes. If you look at a cell, you will see that it is surrounded by an aqueous environment on the outside and the inside. Focusing on the membrane again, we see it is made of two layers of phospholipids. If you were to drop phospholipids in water, this is how they naturally assemble. The hydrophilic phosphate heads are on the outer surfaces of the membrane bathed in water, and the hydrophobic fatty acid tails make up the interior of the membrane, where they are excluded from water. So you can imagine how early cells might have formed from lipids organizing themselves into a bilayer to create a membrane-bound droplet. In this early cell, the hydrophilic or water-attracting heads form the most outward membrane layer, with the hydrophobic tails facing inward. All you need is a special lipid and water.